Triple evacuation, the critical process you need to know for reliable refrigeration and AC systems. Triple evacuation, the critical process you need to know for reliable refrigeration and AC systems. Initial evacuation. The initial evacuation is the first step in the triple evacuation process, and it involves removing any loose debris, dirt, and other contaminants from the refrigeration or air conditioning system. This is done by using a high-quality vacuum pump to create a vacuum in the system, which then pulls out any contaminants that are present. To perform an initial evacuation, the presenter should begin by connecting the vacuum pump to the system. They should ensure that all of the access ports and valves are closed, and that the pump is connected to the correct port or valve. It's important to use a high-quality vacuum pump that can create a deep vacuum, as this will ensure that all of the loose debris and contaminants are removed from the system. Once the vacuum pump is connected, the presenter can turn it on and begin the evacuation process. They should monitor the pressure gauge on the pump to ensure that the pressure is dropping as expected. The length of time needed for the initial evacuation will depend on the size of the system, but generally, it should run for at least 30 minutes to an hour to ensure that all of the loose debris and contaminants are removed. During the initial evacuation, it's important to keep an eye on the pressure gauge and make sure that it remains stable. If the pressure starts to rise, it could indicate that there is a leak in the system, and the presenter should stop the evacuation process and check for leaks before continuing. Overall, the initial evacuation is an important first step in the triple evacuation process, and it's essential to remove any loose debris and contaminants from the system before proceeding to the next steps. Leak detection and repair. After performing the initial evacuation, the next step in triple evacuation is to check the system for leaks. This is an important step, as even small leaks can allow moisture and air to enter the system, which can reduce its performance and reliability. To check for leaks, the presenter should use a leak detector, which can detect the presence of refrigerant gas in the air. The detector should be used to check all the fittings, connections, and components of the system to ensure that there are no leaks. It's important to be thorough during this process, as even small leaks can have a big impact on system performance. If any leaks are detected, they must be repaired before proceeding with the triple evacuation process. The presenter may demonstrate how to repair a leak, which typically involves replacing a faulty component or tightening a loose connection. It's important to ensure that the repair is done properly and that there are no more leaks before proceeding with the next step. Once all leaks have been repaired, the presenter should perform another vacuum on the system to remove any air or moisture that may have entered during the leak detection and repair process. This step is similar to the initial evacuation, but it may be shorter in duration, as the system should already be relatively clean at this point. Overall, leak detection and repair is an essential step in the triple evacuation process, as it ensures that the system is free from leaks and ready for the next steps. By taking the time to check for leaks and repair any that are found, the presenter can ensure that the system will perform optimally and have a long service life. First evacuation. After the leak detection and repair process, the next step in triple evacuation is to perform the first evacuation. This step involves creating a deeper vacuum in the system than the initial evacuation, to remove any residual moisture, air, or other contaminants that may still be present in the system. To perform the first evacuation, the presenter should connect the vacuum pump to the system and close all the access ports and valves. It's important to use a high-quality vacuum pump that can create a deep vacuum, as this will ensure that all of the residual moisture and contaminants are removed from the system. The first evacuation should be maintained for a longer period of time than the initial evacuation, typically between 2 to 4 hours, depending on the size of the system. During this time, the presenter should monitor the pressure gauge on the vacuum pump to ensure that the pressure is dropping and remains stable. It's also important to note that during the first evacuation, the system may release small amounts of oil or refrigerant, which is normal. This is a result of the vacuum pressure and should not be cause for concern. However, if the pressure starts to rise, it could indicate that there is a leak in the system, and the presenter should stop the evacuation process and check for leaks before continuing. Overall, the first evacuation is a critical step in the triple evacuation process, as it ensures that all residual moisture, air, and other contaminants are removed from the system. By creating a deep vacuum and maintaining it for a sufficient amount of time, the presenter can ensure that the system is clean and ready for the next steps in the triple evacuation process. Nitrogen purging. After the first evacuation, the next step in triple evacuation is to perform a nitrogen purge. This step is designed to remove any remaining moisture or contaminants that may still be present in the system, even after the first evacuation. To perform the nitrogen purge, the presenter should introduce nitrogen gas into the system, which creates a positive pressure that helps to force out any remaining moisture and contaminants. The nitrogen gas should be flowed through the system for a period of time until all the moisture and contaminants have been removed. It's important to note that the nitrogen gas used in this step should be dry and clean, as using contaminated or wet nitrogen can actually introduce more moisture or contaminants into the system. The presenter may demonstrate how to properly introduce nitrogen gas into the system and how to monitor the pressure gauge to ensure that the pressure is rising and remaining stable. The duration of the nitrogen purge will depend on the size and complexity of the system, as well as the level of moisture and contaminants that were present. In general, the nitrogen should be flowed through the system for at least 30 minutes to ensure that all moisture and contaminants have been removed. Once the nitrogen purge is complete, the presenter should perform another vacuum on the system to remove any nitrogen gas that may have been introduced, as well as any other remaining moisture or contaminants. This vacuum should be maintained for a shorter period of time than the first evacuation, typically between 30 minutes to an hour. Overall, the nitrogen purge is an important step in the triple evacuation process, as it ensures that all remaining moisture and contaminants are removed from the system. By using dry and clean nitrogen gas and flowing it through the system for a sufficient period of time, the presenter can ensure that the system is clean and ready for the final step in the triple evacuation process. Final evacuation. After the nitrogen purge, the next step in triple evacuation is to perform the final evacuation. This step is the last and most important step in the process, as it ensures that the system is completely free of moisture, air, and other contaminants. To perform the final evacuation, the presenter should connect the vacuum pump to the system and close all the access ports and valves. It's important to use a high-quality vacuum pump that can create a deep vacuum, as this will ensure that all of the remaining moisture and contaminants are removed from the system. The final evacuation should be maintained for a longer period of time and at a deeper level than the previous evacuations. The presenter should monitor the pressure gauge on the vacuum pump to ensure that the pressure is dropping and remains stable. The vacuum should be maintained for a period of time depending on the size and complexity of the system. Typically, the final evacuation can last between 30 minutes to several hours. During the final evacuation, the presenter should also check for any leaks in the system by monitoring the pressure gauge. If the pressure starts to rise, it could indicate that there is a leak in the system, and the presenter should stop the evacuation process and check for leaks before continuing. Once the final evacuation is complete, the system should be sealed and left under vacuum until it is ready to be charged with refrigerant. It's important to keep the system sealed to prevent any moisture or air from re-entering the system before it is charged. Overall, the final evacuation is a critical step in the triple evacuation process, as it ensures that the system is completely free of moisture, air, and other contaminants. By creating a deep vacuum and maintaining it for a sufficient amount of time, the presenter can ensure that the system is clean and ready for the next steps in the refrigeration process. Conclusion. In conclusion, the triple evacuation process is a crucial step in ensuring that refrigeration and air conditioning systems operate efficiently and effectively. By removing moisture, air, and other contaminants, the system can perform at optimal levels and prevent costly breakdowns. The 5 steps outlined in this video, initial evacuation, leak detection and repair, first evacuation, nitrogen purging, and final evacuation, are essential to ensuring that the system is completely free of contaminants. By following these steps, you can help to extend the life of your refrigeration and air conditioning system and avoid unnecessary repairs and downtime. So, make sure to implement these steps in your system maintenance process to keep your system running smoothly.